Hello, I'm Professor Kagan, and today we will be learning about e to the x and how to derive e to the x using multiple different ways. Now first, to do this, you must know what e is, and e is the number defined by the limit. So, to start off your problem here, you have to get a marker. Then, you write the equation. E equals the limit as x approaches infinity as 1 plus 1 divided by x, close parentheses, all to the x. And this whole equation right here is the same thing as equaling about 2.7. which is what e is. Now when you do this, you can also draw the graph. And when looking at the graph, e to the x looks somewhat like this drawing, which I'm about to do, and passes through the point 0, 1. So as you can see, e to the x is between 2 to the x and 3 to the x. It passes through the point 0, 1. Now, my fellow professors will display two different ways to derive e to the x.
Hi, I'm Professor Ned, and now we are going to derive e to the x. First, we can start with the equation of the derivative of the value of ln of e to the x. Now, we can cancel out these two terms to get d, so that's equal to the derivative of just x, which we all know is equal to 1. So, if we then apply chain rule to this equation, we can make it the derivative of e to the x times 1 over e to the x. And since we just did this, we know that this value is equal to 1. So, by then multiplying both sides of the equation by e to the x, we can then prove that the derivative of e to the x is in fact equal to e to the x.
Hello, I am Dr. Professor Malofsky, PhD, and I will be assisting my professors Ned and Professor Kagan today and showing you how you can derive e to the x in a separate way using limits. So I will start out by writing the equation. This is the equation that we will be deriving. We will be proving that f to the x, e to the x, is the same thing when it's prime, equals e to the x. And now we will derive this equation and show just how interesting this is. This is our first step. This is f prime. Now we're going to continue to derive. Our next step will be down here for everyone watching this. This is what we have here. This will then equal this is what we have now. Now our final step will be this. I will be putting a little lower to fully display this. Now this will finally equal e to the x. Now for anyone curious as to why, this section right here is the same as up here, and as we know, the limit of e to the h minus 1 over h is equal to 1. So essentially we're just saying e to the x times 1, which equals e to the x. Therefore proving that this is true. Thank you. This is Professor Malowski. Okay, no, welcome. I am Professor Malowski. Hello, I am MC, Dr. Professor Malowski, PhD, Senior, Junior the Fourth, trademarked and copyrighted. Now, as of about 2 hours ago, and a failed art student who attempted to take my math exam, they tried to turn e to the x into something rather abnormal. I will show you just what they tried to do. First, we have e to the x. Rather simple, it's a beautiful thing. We're going to continue. Apparently, that's our next step. Apparently e to the x can have a horn and an eye. Now we're going to keep progressing. Apparently as well, e to the x can acquire teeth. Now our final step, I'll be very honest, I don't know how evolution works this way. This is a very rapid transformation. Apparently, e to the x can become a dinosaur. Now, I will advise you this will probably fail if you write this as an answer on your test. But it is a wonderful piece of art. Thank you, and this was MC Malowski.